Alright, this is section 4.3. We just finished up talking in 4.1 about using graphing method or numerical method using a table in order to find a solution to a system of equations, system of linear equations. There's another method that we're going to learn in here. It's called the elimination method. Alright? And so, first off, it works on the basic premise of this. There's a basic premise that if you had 2 equals 2 and 3 equals 3, you can add the left-hand sides of both of these equations and get a new equation that is also true. And so by using this, we can combine two equations, add the left-hand sides together, add the right-hand sides together, get a new third equation that is also going to be true. Now, when we look at these equations, at least with the beginning few problems that we look at, they're going to be lined up in a perfect way for us to be able to do this. So when we add x plus y and x subtract y together, on the left-hand side we get 1x plus 1x is 2x, and 1y minus 1y is 0y, or no y's at all, right? And 20 plus 4 is 24. So you get 2x equals 24, divide by 2, and you get x equals 12. Now, once you have 12, you can plug it into either equation to figure out the other part. So 12 plus what equals 20? Well, it's got to be 8. So 12, 8 is the answer to your problem. So on this one, it's lined up just right. When you add these, your y's are going to go away. And you're going to get 5x equals 10. So if 5x equals 10, x has to equal 2. Now you plug 2 in for x here, and you can figure out what y is. Now here, if you add these together, your 2a and minus 2a go away, and you get 1b and 3b is 4b. 4b equals 4, so if 4b equals 4, b has to equal 1. Then you go back and plug it in and figure out what the other one is. Right? And so, when they're lined up nicely, the elimination method is not that tricky, right? But sometimes they're not lined up right. So if you look at this one, if you add these right the way they are right now, you get 7x plus 2y equals negative 12. And that doesn't help at all because it didn't eliminate either variable. You get 5x minus y equals 6. And again, it didn't eliminate either variable. But what we can do is we can multiply one equation by a number and create a new equation. So if we have 2 times 2 equals 2 and 3 equals 3, we can multiply both sides by 6 and we get 12 equals 12, and the second equation is still 3 equals 3. And we can still add them together and we get a new equation that's also true. So, as long as you multiply both sides of the equation by the same number, you can do this. Now, if we line it up right so that the y's will be opposite, like here, then we're going to get rid of our y's and we can nail down what x is. So, how do you get it so that they're opposites like that? Multiply the first equation by 3. But you've got to multiply everything by 3. The 5x, the minus y, and the minus 11. So 5x times 3 is 15x. Negative y times 3 is negative 3y. Negative 11 times 3 is negative 33. And now when you add these, the y's go away and you get 17x equals negative 34. And now you solved it and you got x equals 2. And once you get that, you can plug it into either equation to get the y. Now in this one, it's a little bit trickier because you can't just multiply one thing by one number. Sometimes you have to multiply them by 2 different numbers, right? They don't really show it too well there. Let me try and write a nicer explanation for you here. So if you start out with, where's the original equation? 3x plus 2y equals 1, and 2x minus 3y equals 5. Now, there's no way that you can multiply either equation by one number and your variables will become opposites, and when you add them, they go away. So you're going to have to multiply by 2 numbers. Now, you can get rid of the x's or get rid of the y's. If you're going to get rid of the x's, you typically multiply this one by 2, because that's a 2, and you multiply this one by a 3, because that's a 3. And you make sure that they're opposite signs when you do the multiplication. So now you're going to get minus 6x and plus 6x. And that gives you minus 6x minus 4y equals minus 2. And positive 6x minus 9y equals 15. And now when you add them, your x's go away and you get minus 13y equals positive 13. Divide by minus 13, y equals negative 1. And once you know that y equals negative 1, you can plug it into either equation and figure out what x needs to be. So 3x plus 2 times negative 1 equals 1. So 3x minus 2 equals 1. Add 2. That gives you 3x equals 3. Divide by 3. X has to equal 1. So 1, negative 1 is your answer there. Now notice I multiplied the first one by a 2 and the second one by a 3 to get rid of my x's, and I had to make one of them negative here because otherwise I would have gotten 6x and 6x. I want them to be opposites, not just 6x and 6x, but minus 6x and positive 6x. And I can take the exact same problem and I can get rid of the y's. Watch how I do that. So we take 2x minus 3y equals 5. And this one has a 3, so we multiply by 3. That one has a 2, so we multiply them by 2. And so we're going to get 6y and minus 6y, so we don't have to change the signs. They're already going to be opposite signs already. So what do we get? 9x plus 6y equals 3. And 4x minus 6y equals 10. And now when you add them, your y's go away, and you get 13x equals 13. Divide by 13, you get x equals 1. And you can plug it into either equation. So 3 times 1 plus 2y equals 1. Or 3 plus 2y equals 1. Subtract 3. 2y equals minus 2. Divide by 2. Y equals negative 1. And so you get 1, negative 1, just like we got with the first one. So you can multiply each one by whatever number the other one has. This one has a 3, so hit that one with a 3. That one has a 2, so hit that one with a 2. And make sure they're opposite signs. Or here, this one has a 2, so this one has a 2, so hit that one with a 2. That one has a 3, so hit that one with a 3. And they're going to be opposite signs already. So here you're getting rid of the y's and you know what the x is. Here you get rid of the x's and you know what the y is. Doesn't matter which one you solve for. You're going to get an answer either way. 1, 2, 3. Yeah. And so that's your basic idea in this section here. So let's look at some sample problems here. Question 15 is your first problem that you'll see on your homework assignment. This is the order in which you're done on your homework. All right. So question 15, it's already lined up nicely, so you just add them and your y's go away, and you can nail down what x is. And now plug in 6 for x and you figure out what y is. And same thing here, you add these and your x's go away and you know what y is now. You plug that into the second equation for y and you know what x is now. Now in this one, if you add them the way they are, you'll get 5u, you'll get 3v, and nothing goes away. But if you see that that one has a 2v and you make that one into a minus 2v, then your v's could go away. So if you multiply the second equation by negative 2, it lines up nicely because you multiply by negative 2 everywhere on the second equation, and it gives you minus 4u, minus 2v, plus 18. And you still have the first equation there. And now when you add them, your v's go away, and you get minus 1u equals positive 2, or u equals negative 2. So now once you know u is negative 2, plug it into either equation, you can figure out what v is. Now in 30, let's say you don't see that you need to multiply this one by 3 so that you get minus 3v and plus 3v. Let's say you want to get rid of the u's. You can do that. If this one has a 3, multiply that one by 3, and multiply this one by 5, and then flip one of the signs of one of them, and then your u's will go away. So it doesn't matter which variable you get rid of, but sometimes you only have to multiply by one number. So here we multiply by 3, and we get this guy here. We still have the second equation. Now when we add them, our v's go away, and we know what u is. And we plug that number in for u into the either equation, and we can figure out what v is. And here, if you multiply by 2, you get minus 10x and plus 10x. And here you're going to end up, your y's are going to stick around, and you finally know that y is 9/5. You plug that into either equation and solve it, and you get x equals 4/5. And so 4/5, 9/5. Kind of a weird problem, but there you go. Alright, in this one you've got to multiply by two numbers. There's no way around it. So I chose to multiply this one by 3 and this one by 5, and I flipped the sign of one of them. So now I'm going to get minus 15x and plus 15x. Okay, remember you got to hit every single term, both sides of the equation, every single term by that number, whatever it is. Okay, and now when you add them, your x's go away. You can solve for your y. And now you can, this is called back substitution, where you plug in what you now know into either equation, and you nail down what the other guy is. Okay, and now this one, if you add them already, the minus 1/4 y plus 1/4 y, they're going to cancel each other out. And so you get 3x, minus 3x equals minus 5, so x equals 5/3. And now you plug that in to either equation, and I multiply by 12 to get rid of all my fractions. Makes my answer easier to work out. And then when I solve it, I end up getting a fraction. Notice when you get rid of your fractions in the middle of the problem, if your answer is a fraction, you don't see the fraction until the final answer, and it's kind of nice because then you don't have to deal with common denominators and all that other stuff. So 5/3 and minus 28/3 is your answer to that one there. Alright, now here's some word problems. It says, doing strenuous exercise, an athlete can burn 9 calories per minute on a stationary bike and 11.5 calories per minute on a Stairmaster. So, how many minutes of each should they spend in order to burn 300 calories? So x minutes plus y minutes equals a total of 30 minutes, and x can be the stationary bike, and y can be the stair climber. And so now the total number of calories is the number of minutes times 9, number of minutes times 11.5. So you got your two equations, two unknowns. You multiply by -9 so your x's go away. And you solve it and you get y equals that. And now once you know y is 12, the other one has to be 18 because they have to add up to 30. Right? And so there you go. And typically when you have word problems, you want to not only tell me what x and y are, but you want to don't just say 12 and 18. You got to say 12 minutes on the Stairmaster and 18 minutes on the bicycle. Right. And then there's a number of problems here. 61, 62, and 63 are problems that are all very similar. And I made a whole series of questions that I'll talk about at the end of this section here. But the first idea is a riverboat takes 8 hours to travel 64 miles downstream. Okay, so imagine this is upstream and here's your river. Okay, so going upstream versus downstream. Okay. So a river takes 8 hours to travel downstream, 64 miles. So we know the total distance they're traveling is 64 miles, right? Total. And 16 hours to go back upstream. So it takes you twice as long to go back up than it does to go back down. Well, the reason for that is because when you're going downstream, you have the speed of the riverboat, but you also have the speed of the current propelling you even faster. It's just like if you're walking on a flat escalator, right? So you've got to consider that when you're going downstream, you've got the speed of the riverboat plus the speed of the current. They add together, and that times the amount of time of 8 hours gives you a total distance of 64 miles. Distance equals rate times time. Right, your distance you've traveled is your rate or speed times the amount of hours you've traveled at it, right? 60 miles an hour for 3 hours is 60 times 3 or 180 miles, right? So the river's current plus the riverboat plus the current add together, and that times 8 gives you the 64. And when you go back upstream, the riverboat's speed take away the current speed because it's fighting you as you go back upstream, it's taking you twice as long, 16 hours. Right? So when you multiply each one of these by 8 and by 16, you get these two guys, and then it's just a matter of solving it like we've been doing, where you multiply one of them by 2, and now your C's are going to be opposite, and they're going to go away, and you can now figure out what R is. And once you know what R is, you can go back and plug it into either equation to figure out what C is. So the boat travels at 6 miles per hour. The current is 2 miles an hour. So when you're going downstream, you're going 6 plus 2, which is 8. 8 miles an hour for 8 hours is 64 miles, right? Now when you're going upstream, you're going at 6, but it's taking away 2 of that because of the current. So you're really only traveling upstream at 4. 4 miles an hour times 16 hours is 64 hours. So again, 6 plus 2 and 6 minus 2. It's with the current and without the current. And the same thing works for an airplane, right? An airplane travels 3,000 miles either way. One is with the wind and one's against the wind. And with the wind, it's only 5-hour flight. Against the wind, it's 6. Makes sense. It takes more time when the wind is against you, right? And so you got the airplane plus airplane speed plus the wind speed. Airplane speed take away the wind speed. And it's 5 hours, 6 hours, and they're both the same distance, 3,000 miles. So you multiply by 5 here, and you get this guy here. Multiply by 6, and you get this guy here. And you multiply a 6 and a 5 so that your W's go away, and you're able to figure out what A is. And once you know what A is, you plug it into either equation to figure out what W is. Alright? Number 48, they give you an equation already, and you multiply by 2, and it lines up your X's so they go away. And also your Y's go away. This is interesting. So when you get a true statement like this, that means you have a solution when 0 equals 0, which is always true. So it's infinitely many solutions. If you graphed it, you'd see the exact same line right on top of itself. Now on this one, when you solve this one, you get 0 equals negative 3. Well, there's a solution when 0 equals negative 3, which is never. So there's no solution. When you graph this, you see they don't intersect at all. No intersection. Right. Now I wrote up a series of questions here. I wrote up 3 of each type. So I wrote 3 riverboat questions. The first one we already did. The second one is slightly different numbers, and the third one's even slightly different numbers after that. And so I will be including this in my documents in the Canvas files. But this is 61, just like we did it already. And this is 61 with slightly different numbers. And this is 61 with slightly different numbers yet. It's the same question, just answered 3 different ways. Right. And 62, which is the plane, we already did, I think we did this one. Right? And I came up with 2 others that are similar questions. 3,500 miles, 10 hours with the wind, 14 hours against the wind. 2,800 miles, 7 hours with the wind, 10 hours against the wind. And then 3,000 miles, 5 hours with the wind, 6 hours against the wind. Yeah. And so each one, I have them worked out completely, so you can see 3 different examples of that. The only one that's not included in your homework that is a problem that's important is 63. 63C is the original question you find in your textbook. It says, a total of $5,000 is invested at 3% and 5%. After 1 year, the total interest is $210. How much money is invested at each rate? So you have 2 equations. One that talks about the money invested in this account, the money invested in that account equals the total money invested. And then the interest rate earned on that amount of money plus the interest rate earned times that amount of money equals the total amount of interest. So this is interest plus interest equals interest. This is money invested plus money invested equals total money invested. So x plus y equals 5,000. So you invested 5,000 in 2 different increments. And you invested some of it at 3%, some of it at 5%. And it will add up to $210 in interest. And so you got 2 equations here. And if you want to get rid of one of your variables, if you multiply this one by negative 3, you get negative 3x. And if you multiply this by 100, you're going to get positive 3x. So minus 3 and 100 is going to give you numbers that will get rid of your x's. And when you add them, your y's are solved for. And remember, it's y is 3,000 at 5%. And the other one is the other amount. So 3,000 plus what will give you 5,000? It's got to be 2,000. And 2,000 at 3%. And so then these other ones are the same idea. It's just a different set of numbers, different set of amount of interest. But it's the same concept here. You got a certain amount of money plus another amount of money equals a total amount of money. And a certain amount invested at each of these interest rates gives you a total amount of interest. And you can solve that one. Same thing here. Two different amounts that add up to 4,000 and two different interest rates that give you this. And you can add them together. And keep in mind, when you come up with an answer for x and y, you want to not only state the dollar amount, but you want to state what the interest rate for that dollar amount is. Right? And so I give you 3 examples of that in your document camera, or in your document files on your Canvas page.